Hello, this is Dr. Lennon, and we want to talk about trigonometric ratios today. So basically, these are based on a right triangle. So let's say, given a right triangle, and let's say we draw it like this. So we have our right angle here. So let's say this is side C. We have side A here and side B here, and then maybe we call this capital side. This angle capital A and this angle capital B. Normally, the angles are set up so that they're opposite their sides, meaning capital A, that angle opens to side little a. So the same letters are kind of opposite each other's. So let's recall in the above right triangle, C is the hypotenuse, and that's all the hypotenuse means is the side opposite the 90-degree angle. And A and B are the legs, meaning that they are the two shorter sides. So historically, what we talk about when we define these trig functions is these are just ratios of sides based on the angle that you're talking about. So when you talk about these ratios, what they are is sine, cosine, and tangent, and they're given by they're remembered according to this really popular mnemonic device known as SOHCAHTOA, SOHCAHTOA. And what that means is the sine of some angle is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. And the thing is, based on how your right triangle is written, these things are going to change around because they are from the perspective of a particular angle. The hypotenuse is always going to be the same because the right angle is stationary. However, when you're talking about opposite and adjacent, it depends on what you're talking about. Are we talking about angle capital A or are we talking about angle capital B? There's two perspectives that you can take there, and that's going to change depending upon which angle we're talking about. So let's go ahead and look at an example where I write down some specific numbers so that we can actually tell. So in this example, let's say find the sine, cosine, and tangent of angle A and angle B. Given, so let me draw you a triangle. So let's say this triangle looks like this. So here's our right triangle, and let's say the side lengths are 5, 12, and 13. And let's say this angle is angle A, and this angle is angle B. So basically what we want to do is we want to write down the 6 ratios. So we want to write down sine of angle A, cosine of angle A, tangent of angle A. So we want to write what those 3 ratios are. And then we want to do the same thing, but we want to do it from the perspective of angle B. So if we're talking about angle A opens to the side 5. And 13 is the hypotenuse no matter what we're talking about. So as we saw above, sine is SOH, so that's opposite over the hypotenuse. So 5, from the perspective of angle A, 5 is opposite, and the hypotenuse is always 13. So this trig ratio, sine of A, is 5 over 13. For the cosine of A, we're still from the perspective of A, but now we're looking at the adjacent side, the side that forms the angle with the hypotenuse. So the adjacent side here is 12. So since cosine is adjacent over hypotenuse, this ratio would be 12 over 13. And then finally, the tangent is the opposite over the adjacent. So the tangent of A is the opposite side 5 over the adjacent side 12. Okay, now B, what's going to happen? Well, the things are going to change because now we're looking at, suppose we're standing at the vertex B, that angle. Now the hypotenuse is unchanged. The hypotenuse is still 13, but the opposite side now becomes 12, and the adjacent side that forms the angle of B with the hypotenuse is 5. So if we're looking at the sine of B, the opposite side is now 12. So we have 12 over 13 for the sine of B. The cosine of B would be the adjacent side 5 over the hypotenuse 13, and the tangent of B would be the opposite side 12 divided by the adjacent side 5. So notice, from the perspective of angle A versus the perspective of angle B, all pairs changed. So the hypotenuse is the same, and sine and cosine being in the denominator, that's always 13, but what we call the opposite side versus what we call the adjacent side has changed. So that is the thing that we want to think about when we're defining these trig ratios. And we'll see in a little bit that these things are actually used to find unknown sides and angles of triangles. But today we just want to introduce those things and write them down. So let's try another example, kind of going through the same thing. Again, let's just say let's do just one set of, well, let's do both sets. Okay, so find the, how did I write it before? Find the sine, cosine, and tangent. So find the trig ratios of A and B given. So let's write a new triangle. So let's say this one looks like, I don't know, this. So this is our right triangle. Let's say this is 5, this is 3, and this is 4. So if I were you, I would go ahead and pause the video and see if I could fill these things out. Again, it's going to work exactly the same way as we did in the previous example. And you just need to change the perspective when we're talking about each of those things. So let's go ahead and write down which angle is which. Let's say the top one is angle A here, and the bottom one is angle B, bottom right. So go ahead and pause the video and give yourself a shot and try to figure out which angle or which trig ratio applies to each of the ones listed below. Okay, so let's go ahead and work them out. So 4 is opposite of A, so the first one is going to be 4 over 5, which makes the adjacent side 3. So the cosine has to be 3 over 5, 5 being the hypotenuse, and the tangent of A would be 4 over 3. Similarly, if we go to B, from B, the opposite side is 3 and the adjacent side is 4. So once you've identified those things, the ratio should be no problem. So the sine becomes 3 over 5, the cosine becomes 4 over 5, and the tangent now becomes 3 over 4. So those are the trig ratios there. Okay, so that's it for identifying the trigonometric ratios. So for many angles, we have a calculator, and it can identify what those ratios are based on knowing the angle in the triangle. So let's talk about how to measure the angle. So we know that in a right triangle or in any triangle, the sum of the three sides adds up to 180 degrees, and in a right triangle, one of those sides is 90 degrees. But there's also another way to measure an angle that's very common in trigonometry, known as radian measure. So a lot of times when we talk about trig functions and we're doing trig values in our calculator, it will be important to know whether or not we're talking about degree measure or radian measure. So let's talk about radian measure. So um, radian measure is really based on the circumference formula of a circle. So 1 radian, the definition of is the way to think about it is completely visual. So if you have a circle and you think about the radius of a circle, if you would take that same length and stretch it out as an arc along the circle, that arc, so if you imagine the length of this thing right here were r, that angle right there would measure exactly 1 radian. So a lot of times we use theta to define for an angle name in trigonometry, but 1 radian is the angle formed, technically I should say central angle, so let's add that in there, is the central angle formed in a circle corresponding to an arc length of exactly 1 radius of that circle. That's just a good thing to think about in terms of understanding the definition. A lot of people will say, okay, well, I know the conversion factor, which is good, but I think it's helpful visually to understand that the real definition is based on understanding that you have that radius, and imagine if it were like a piece of rope, you could stretch it out and then say, okay, well, this is exactly what it looks like. That's how you would come up with that idea. So since we know from the circumference formula that we just looked at in geometry, so recall the circumference of any circle is equal to 2 pi r, we know that 2 pi radiuses go all the way around the circle one time. And from geometry, we know that's equal to 360 degrees. So therefore, we can say 360 degrees is equal to 2 pi r. And sometimes if it's clear that we're talking about radians, we won't have any symbol associated to it like we have the corresponding degree symbol. But if I want to be clear, I will just write RAD next to it. Or there's a factor of 2 on both sides, so we can divide by 2 and say, okay, 180 degrees is the same thing as pi r radians. So we can use that information to convert back and forth between measurements. So let's see an example where we use this both ways, and it'll come up later. So let's say first we want to convert. Let's convert some degree measurements to radian measurements. So convert to radian measure. So let's say we start with 45 degrees. Well, what you do is you just multiply so that you want to cancel out the degree measurement and leave yourself with radians. So basically what we'd want to do is, since we have degrees, we want to cancel that. So our degree measurement will go in the bottom, 180 degrees. And actually, so I was using pi r. So r is the number of radiuses in that circle, or radii in that circle. So I was actually a little bit extra on this. The number of radians in a circle is just 2 pi radians. So so we can say, hence, there are 2 pi radians in one circle. no matter how big the radius of the circle is, there are exactly 2 pi copies of that radius on the circle. So 360 degrees just corresponds to 2 pi radians. I didn't mean to write down 2 pi r radians. That was a mistake. So the angles are just based on 2 pi is 360 and pi is 180. We don't have to care about what the radius is. So anyway, so to convert this 45 degrees to radian measure, we need to multiply by pi over 180. And so that would come out to 45 pi over 180, which simplifies to pi over 4. So that's pi over 4 radians. Sometimes you would convert that number to a decimal. And if you did, that would come out to 0.79 if we round to 2 places, something like that, about 0.79 radians. So these things are very different in terms of their numerical value typically. Let's do one more. Let's say we want to convert, let's say 60 degrees. So again, you just multiply by pi over 180. And this would come out to 60 pi over 180, which would be pi over 3 radians. And you could get a numerical value. And this comes out to about 1.05 radians. So these numbers are a little bit different than we're used to for measuring angles, but the thing about it is it's not based on some arbitrary notion. It's based on a geometrical fact about a circle. And let's go the other way. Let's say, example, we want to convert to degree measure. Well, we had that definition based on the arc length of the radius. So maybe an interesting question is, well, how much is 1 radian? If we wanted to know what is the degree measurement of 1 radian, you could kind of visualize that and maybe guess an estimated value. But what do we do here? Well, now we want to cancel out radians. So we want the degrees on top, 180 degrees, and we want the radians on the bottom. So this would come out to exactly 180 over pi degrees, and we would want to do that in our calculator. So 180 divided by 3, we can estimate, or divided by pi, and we can see that's going to be a little bit less than 60. But what does that come out to? About 59.30 degrees. Let's do one more. What if we said, how much would pi over 5 radians be? See, if they're a multiple of pi, normally they're going to come out to a nice even unit in terms of degree measurement. So if we multiply here again by 180 over pi, the radians will cancel and we'll be left with degrees. So this is 180 over 5 degrees. The pi's will cancel, and that comes out to 36 degrees. So that's how you convert back and forth. And then the one kind of warning is when evaluating a trig value in your calculator, you must make sure it is in the correct mode. So on your calculator, you can typically switch from either a degree mode or a radian mode, and you need to, that's going to differ from calculator to calculator. Normally there's a button that says mode and you can check. So one way you can check is we can say, okay, let's say example, so let's say find each value in your calculator. And a lot of times, these will just throw you off if you're accustomed to working with one all the time and all of a sudden you switch. So let's first say we want to figure out the sine of 40 degrees. Okay, so if you do that in your calculator, hit your mode button and make sure it's on the degree mode. And then once you've done that, you can just hit the sine button and make sure to put 40 in parentheses. And then that should come out, if you did it properly, to about 0.64. That was degrees. But what if it were radians instead? What if we were doing sine of 40 radians? So we haven't talked about how to define sines of things bigger than 90 degrees, because we haven't moved outside the right triangle yet, but there is a way to do it. So let's suppose it's 40, but we don't mean degrees, we mean radians. So the calculator should give us a different answer. So if we hit mode and now change to radian mode, and we type the same value, sine of 40, we don't get the same number. Instead, we get about 0.75. So notice that the values are completely different. So if you're not using the appropriate mode in your calculator, you're going to get a different number. So if you're asked to find the trig value of a specific thing, then you need to make sure your calculator is in the appropriate mode. So that's it for this lecture. We will talk soon about how we can use these trigonometric ratios and the values given by our calculator to solve for unknowns in right triangles. Okay, so this is Dr. Lennon signing off.